YouTube. In this video we're going to be talking about the fourth major way of representing a function, and that is with a rule, okay? And so we say functions and their rules, okay? It's kind of how we're going to look at this video here. But how do we represent a rule with a function, or a function with a rule, pardon me? And the thing is this, a lot of things in math, there are pretty big time patterns that go along with them, okay? And so for instance, if I were to make up some relation here that was a function, and we say 1 is my input, 2, 3, 4. So our domain is, they are 1, 2, 3, and 4. If I were to say 2, 4, 6, and 8, what I want you to realize, in every instance of y, we say it's really just double the x. So another way we could look at this is we could say, well, if this is the case, what we could do is we could generalize this using a rule, okay? And a rule is just a general way of saying, here's how you find an output given an input. So a rule basically is a plan, I guess we could say. A plan for determining an output given some input, okay? And notice we're using the words input and output here, domain and range. But essentially, what we could do is we could say this up here, we say the output y is equal to just take 2 times the input x, and this would be our rule, okay? And so this is an example of a rule. What we're going to do is we're going to start looking at rules a little bit differently in this section. So before we do that, let's go ahead and hit some key vocabulary here, starting with this. This is referred to as the equation, okay? When we talk about a rule, we tend to represent it with an equation, okay? And our equations, for now at least, are going to involve some x and some y, okay? When you look at this table up here, we're going to give this table a name, okay? This is a table of solutions to this rule. And the reason why I call them solutions is because if I were to take, say, for instance, some point here, we say 4, 8 was on the graph of this, and we say this is some x that went to some y, some point. If we were to take this now and plug it or substitute it into the rule here, and their appropriate places, mind you, so we'd say, for instance, y, we would plug in an 8 wherever we see a y, and plug in a 4 wherever we see an x. What we're going to see is that this is a solution to the equation. So I want to check this here, actually. We'd say y equals 2 times x, where instead of the x we could put in a 4, and instead of the y we could put in an 8. And what you're going to see here is this: I get 8 equals 2 times 4, which is 8 equals 8, and so this is valid. This is a solution. This would have worked if I had picked any of these points up here. So when we graph functions using rules, what I want you to understand is this table that you're creating up here is really just a table of solutions, okay? When we talk about rules also here, we are going to refer to x as the independent variable. So we say the independent variable, okay? And the reason why we tend to refer to x as being the independent variable is because it's the input variable. It kind of does whatever it wants. You could not tell me the output variable y without knowing what x would have been in the first place. So when people say, when you make this table up here, you put in 1, 2, 3, and 4, how did you know to do that? And what I want you to understand is that it is independent. It may be almost for almost all times, unless there's a restriction, x can do whatever it wants, okay? We're going to refer to y, okay, as the dependent variable. And the reason why it's the dependent variable is because it's the output. That's where it is, okay? So this is our output variable, is our y variable, or dependent variable here, okay? It also tends to be the thing that you're measuring, all right? So moving onward, we say independent, dependent variable. The last thing we're going to do is we're actually just going to graph, say these solutions for this rule right here. So like, for instance, if I was going to graph this, I say 1, 2. It seems like was in our table here. We say 2, 4 is on our graph. 3, 6, 4, 8, okay? And we say this would be our rule right here. We'd say this is y equals 2x. Now, there are a few things we do need to consider here, but one of them is certainly this. We say we plugged in 1, 2, 3, and 4, and we got these outputs up here. We said 2, 4, 6, and 8. But certainly when I look at this graph, we say, could I have plugged in a y value of 1.5 and found an x value? And what I want us to see is that we certainly could have. We could have said, well, what would y be if x is equal to 1.5? We could say, well, we would get 2 times 1.5, which is 3. So the point 1.5, 3, if we were to build this onto our table here, 1.5, 3, it would also be on the graph. The point I want to drive home, though, is this. Essentially, every x value is going to have some y value on this graph. So even though we only graphed 5 points, in this particular instance, what we need to be doing is graphing an entire line. So we're going to connect the dots, and the reason why is because what we are saying is, again, just like these are solutions in the table over here, what we're putting on the graph over here are just these points that we got in the table. So when you graph something here, we're going to write this down. We say this is the graph of the solutions to our rule, okay? And our rule is right here. So all we're doing is graphing the solutions to this. So since we do want to graph this and we do want to create tables a lot of the time, what I'm going to do is I'm going to break it down into 3 steps for us essentially. But we're going to get into some new notation today before we do this, okay? So we say given a function, we could say a function is some rule defined by some rule. We could give a mapping, I suppose, or we could, give a graph already, but we say this is some rule that defines my function, okay? Since we are using this to represent a function, okay, we're going to start renaming this, and what we're going to do is we're going to call it function of x. So instead of y, we say y is some dependent function of x. We're going to refer to this as this, f of x, okay? So let's write a little note here. This is read as f of x, okay? And that is short for, I suppose, function of x. And what we're really saying is y is some dependent thing upon x, okay? So when we look at a function like f of x, instead of y equals, why would I want to do this instead? Why would I want to write it as some x f of x, okay? And the reason why is because what we're saying is this. Let's say I wanted to find the x value of my function here, which is defined by this rule, and I want to find the y values for it. F of x is a fancy way of saying this is your y value when x equals this thing right here. So what we're going to do is we're going to practice filling out a table here. So we're going to start with this. We say f of 1. Now, this is a fancy way of saying, would you go find y when, and we're going to write this here, we say when x equals 1. Because what we're doing is instead of writing an x here, we're plugging in a 1. We say, well, everywhere in my rule now, what I'm going to do is I'm going to take out x, and I'm going to put in a 1. So we put in a 1 here, and we get this. We get 2. So what this means is we get 2, but that's the same thing as saying f of 1. Okay. So before we go any further, let's go ahead and kind of reconfront what this means. F of 1 is a fancy way of saying this is the y value when x equals 1. Okay. So every point in general could really be written this way. Some x value, and then the y value I got when I put that into my function. So for instance, I'm about to find f of 2, say for my table here, we say x, y, we say 1, 2, 3. We already plugged in 1, and we got a y value of 2. So now I'm going to go find f of 2, which means go plug 2 into the function wherever you see in x, and tell me what you get for an output. And our output is 3. Okay. And then this next one here, we get 4, and we could go graph these. Okay. But essentially, when I said I'll break this down into steps for you, what I want to do is I essentially want to start representing functions with rules and then going and sketching all of the solutions by using a table. Okay. So we're going to take a look at a couple of functions that I've listed down here for us and some tables to fill out. But number 1 is always going to be this. 1, make a table. You may hear these called T-charts. They look like the letter T. Okay. But we're going to choose indiscriminate. I don't want to use that word. Basically, choose arbitrary x values. So arbitrary x values. So you'll see in our tables, like over here, I tend to choose, like numbers around 0. You don't have to choose in particular given, numbers, but we say choose arbitrary x values to plug into your table. Okay. So the next thing we're going to do is this. We're going to fill out the table using substitutions. Okay. And the third thing we're going to do is graph the points. And the fourth thing we're going to do, at least with these, is we're going to connect the dots, because these happen to be linear equations. So we say connect the dots on these. Because like we said up here, it does actually exist for all x values. So when we look down here, we say number 1, f of x equals 2x plus 1. The first thing I want to do is I want to make a little mental note here. And let me move this to the front. This is going to help us. Maybe. I think we can write on this here. There we go. Okay, so f of x equals 2x plus 1. We're going to say this is the same thing as y equals 2x plus 1. So we make our table here. You notice that it says x f of x. This is really the same thing as xy. It's just that f of x is saying I'm the function value or the y value at that x value. So when we look at this first one here, we say -3. What we want to do is we want to go find f of -3. Okay, so f of -3 we don't know, but f of -3, keep in mind, all that means to do is this. Wherever we see an x in our function, what we're going to do is we're going to take it out and we're going to put in a -3. So in this case, we get this. We get -6 plus 1. So we get an output of -5 when we input a -3. So we say -5. So now let's try this with -2. We say f of -2 means wherever I see an x, let's take it out, let's plug it in -2, and say what do I get for y value? So we get -4 plus 1, so we get -3. So -3 is our output here. When we plug in 0, I love plugging in 0 because everywhere I see an x, I put a 0 there, it just drops out. And so I get, in this case, 1. So this is 1. When I plug in 1, let's go find f of 1. F of 1 means 2 times input plus 1, where our input in this case is 1. So we'd say in this case I would get actually 2 plus 1, which is 3. And then last but not least over here we say f of 2. We say let's go find f of 2, which means 2 times x plus 1, where our x in this case is 2. And so we get 4 plus 1, so it's 5. So the last thing we want to do is we want to graph this function by just graphing the points. So we say -3, -5, so 1, 2, 3, left 3, down 5. So it'd be this point here. This is a solution. We say left 2, down 3, so left 2, down 3. Okay, 0, 1, so up, left and right 0, but up 1. And we say 1, 3, so right 1, up 3. And then last but not least, we say 2, 5, so right 2, up 5. And we say, okay, so these are the solution pairs that we found. What we want to do is we want to connect the dots. And what we're going to do also is this. We're going to label this f of x equals 2x plus 1. Because what we're really doing is we're graphing all of the solutions to this. Okay, so again, we're going to fill out another table here really quickly, but if anybody ever says go graph the function, what we're going to do is we're always just going to make a table. You notice that I chose random x values here. I just felt like using these here. And again, if I wanted to find f of -6, you start to see how, our rule is, take the input plus 5, add 5 to it this time. If I plug in a -6, I get -6 plus 5 is a -1. But you're going to see we could probably do these in our head. So for instance, if I plug in a -5, we say, what is f of -5? Well, I get -5 plus 5, which is 0. Or -3 plus 5, which is 2. Or 1 plus 5 is 6. Or 3 plus 5 is 8. Okay, so our rule is basically telling us to do this to the input. Let's go graph these really quickly. We say -1, -6, or -6, -1, pardon me. So we'd say here, we've got a point, -6, -1, -5, 0 would be this point here. -3, so left 3, positive 2. 1, 6, and then 3, 8. Okay, and so we get this, what we call a linear function here. It is a function because it does pass the vertical line test. It is 1 to 1. We say this is some function, f of x equals x plus 5. Okay, these are solutions. So that is how you graph a function using a rule, or represent it using a rule.